we have given the graph of the function f by this green curve over here, and then the graph of the function g by the blue graph over here, right? Blue curve over here. We need to use this graph and then see if we can evaluate the limit of this function given over here, the quotient of f and g, and we need to find the limit of that at 0. Okay, so let's try to see if we can find that. Alright, so let's first focus on the problem. So our goal is to find the limit of this quotient of the function f, right, with z at 0. So this is the question. So how can we find that? Do we have any quotient rule related with this quotient of the function? Yes, we do have, right? What is that one? The quotient rule says that we can find the limit of the quotient of the function by finding the, let's say, limit of the function f, okay? At 0 we can do that, and then find the limit of the function g at 0. But do you know when can we use this rule? There was actually some restriction, right? So if you look into if you revisit the quotient rule, you can see that this rule will be only applicable if the denominator, this limit over here, is actually not equal to 0, right? So that's what it's given as the quotient rule. So we need to make sure that even to apply that quotient rule, first of all we need to look into the denominator, if that's what happening, if that limit is not 0 or not. If it is not non-zero, then we can use the quotient rule, but if the denominator is 0, then we'll have a problem. We cannot use this quotient rule. So let's try to see that here. So what is the limit of the function z at 0? So let's go closer and closer to z. That means on this blue curve on the x-axis, let's go closer and closer to 0. So whenever I am getting closer and closer to 0 from the left side and the right side, you can see the y value is just getting closer and closer to that blue curve, is just getting closer and closer to. Wow, I didn't want that, but that's exactly happening here, right? So it turns out that the limit of the function g when x gets closer and closer to 0 is actually 0. The left side limit is 0, the right side limit is 0, right? So and then the limit of that is 0. So if that is the case, we cannot apply the quotient rule here, right? So even you would apply, I mean try to apply, which by the rule it said that we cannot, right? So I mean if mistakenly even you do that, you can see the top is what is the limit of the function, we can find that, but the denominator will be 0, and then if the 0 is in the denominator, is something like undefined, right? So we cannot do that. We cannot have any real number where the denominator is 0. So if that is the case, then we'll have a problem there, so we cannot use this. So but then how can we find the limit of that? Well, I mean, sometimes maybe it's not possible, because in our problem it's clearly written that we need to find the limit if it exists. So maybe it doesn't exist, but how can we confirm that? Is this a sufficient information? Well, probably. I mean, just let's try to see what is the limit of the function at the top. Let's try to see here first, and then we'll again discuss this one. So when we go closer and closer to 0 from on the blue curve, okay, whenever we go closer and closer to 0 from the left and right, you can see the height of the curve is getting closer and closer to that location, which is at what is this one? It's at 5, right? So if that is the case, that is the limit of the function, right? So you can clearly see that this location is over here, is 5. So it looks like the limit of the function g, let me write that information over here. Limit of the function f when x gets closer and closer to 0 is 5. So obviously we cannot use the quotient rule, but that's how the function behave, right? To answer, does it exist or not? So I mean, let's try to see and then try to understand what limit means. How did we define the limits? The limit of a function at certain, like a number or something like that. We say actually we have defined the limit actually as the value of the function, right? So when x gets closer and closer to something, we just want to see how the function behave. So one way what we can do is actually just based on this information, if it's possible, like create the graph of the new quotient function and then see how that behaves, okay? Or the other way is actually, now what you can just do is let's try to see when the function is when x gets closer and closer to 0, how the f of x, where the f of x approaches, okay? And let's say from the left side and then right side, and then each time we just want to see how those behaves. We just want to see the behavior, not just by directly plugging this quotient rule. So let me just go closer and closer to 0, okay, and then from the left side for the function f. So when I do that, you can see that the y value is actually, it's getting closer and closer to that 5. Okay, I know that, but you can see each time maybe somewhere over here is 4.5, then 4.9, and then 4.99, and then so on, and that's how it will go closer and closer to that location, right? So maybe the pattern is something like for the function f, right? So when x gets closer and closer to 0, the f of x may approach to something like, okay, I know this is 5, but how will that approach? Maybe first 4, somewhere, and then it's 4.1, 4.2, and then 4.3, right? And then let's say 4.9, 4.99, and then so on. This is how it will approach to 5, right? So that's what we have seen over here on this curve over here, right? So the height of the curve goes like that. So that's what we have been seeing over here from the left side, and then actually that's the same thing also from the right side, no problem, right? So that's what it is happening. Okay, but now let's try to see how the g function behaves. So you can see here on the g function, whenever we are getting closer and closer to 0 from the left side, the height of the curve is actually decreases and it just gets closer and closer to 0, right? So maybe it is 1, and then 0.5 over here, and then 0.49, right, or 4, 0.3, and then so on. Okay, let's try to see that behavior. So when x approaches to 0, right? So when x approaches to 0, and this is how the function f behaves. Okay, we know that. Okay, let me write down f here just to represent this fact. Okay, and then now let's try to see g, and then we have already discussed that one. The g curve would, maybe it is at 0.5 and then 0.4 and then so on. So let's write that down information. So maybe it is 0.5 and then 0.4, 0.3, 0.1, right? So something like that. It's just, and then maybe 0.01 and then 0.0001 and then so on. So it's just getting in that way, getting closer and closer to 0. And then that is actually from the left side, when x gets closer and closer to 0 from the left side. And when x gets closer and closer to 0 from the right side though, the g curve is actually, let's try to see here what is happening. The g curve, the height is actually increasing. At the beginning it was negative 0.5 and negative 0.4 and then so on, right? So it's just getting closer and closer to 0 in that way. So maybe negative 0.5, negative 0.4, negative 0.3, negative 0.1, negative 0.01, and then so on, right? So maybe this is how it's just getting closer and closer to 0 in that way from the right side. I don't say that exactly this is the pattern behaves at each and every location, but the overall trend is like this. So if that is the case, if you are thinking of let's say when x is getting closer and closer to 0, x is getting closer and closer to 0 from the left side. If you want to see how f over g function behave, you can clearly see here. Definitely it may not be 4 over 0.5 because I don't know the exact location of that one. Where do I get 4 and where do I get 0.5? We can again revisit the curve, but somehow similar pattern is happening. What type of pattern we have? Something like it's 4, 4.1, 4.2. It's something like that divided by probably 0.5 or 4 or 0.4 or something like that. So the numerator is just getting closer and closer to 5, right? Or kind of a fixed number, right? So sorry, not a fixed number, but it's just getting closer and closer to 5, and the denominator is just getting closer and closer to 0, but it's getting smaller and smaller, right? And then it's decreasing and getting closer and closer to 0, right? So if that is the case, can you think about it where the quotient would approach? This look like for me it's actually the ratio. If you can try and then see and then actually if you want to do the perfect job, you can see the graph over there, and then see corresponding to each x values what is the the value of the f and value of the g, divide those and then see how the quotient behaves. But it looks like kind of it's actually getting larger and larger, so which in fact over here we can write down here f over g is just getting the limit is actually, we can say, infinite. We can say that it's just getting larger and larger without any bound. You can check that by your calculator. 4.99 divide by 0.001, or 4.9999 divide that by 0.00001, and then see how that behaves. Okay, you can check that. Or at the same time, in the similar way, we can actually check when x gets closer and closer to 0 from the right side, f over g, right, where that behaves. We can check that again by maybe again do the same thing. 4 divided by maybe negative 0.45, 4.1 divided by negative 0.4, or something like that, similar number or something like that. In that way, try to see where this cosine function approaches, where this approaches. Okay, and my guess is it just actually gets in smaller and smaller, and actually it will be getting let's say decreases without any bound. So if that is the case, we can clearly see that the left side limit is just getting larger and larger, the right side limit is getting smaller and smaller. So definitely on that sense, we can say the limit does not exist. Right, so if you are asking why am I doing this much work, because at the beginning, if we would have just, if this is 0, you would already know, okay, so it is something like we cannot evaluate the limit. Why didn't I write down does not exist? Well, because I mean this is, if you cannot actually plug 0 in over here, because we cannot even use the quotient rule. If we cannot use the quotient rule, then we need to follow the definition. How does that work, right? And to do a perfect job, if you want it, like I said earlier, corresponding to each of these x values on the graph, I don't think that this can, because we don't know what is explicit f and then g, what is the rule that would define this curve, we don't know. We are just relying on this information that we have on this curve. So if that is the case, then definitely some of the number that I have calculated over here is kind of over maybe not matching perfectly corresponding to the x location, but still we can capture those information over here, how overall train behaves, right? And then it turns out this is the behavior when x gets closer and closer to 0 from the left side, the f over z, right? So this cosine function gets larger and larger. When x gets closer and closer to 0 from the right side, this is actually getting smaller and smaller. That doesn't match up, they behave differently from the left and right. So definitely on that case, we can say the limit does not exist.